The topic of the third lecture on Introduction to Chemical Technology is raw materials for chemical technology. Today we will discuss 5 issues, which are general characteristics of raw materials, classification of raw materials and secondary resources, characteristics of raw material base of Kazakhstan's chemical industry, principles of raw materials enrichment, and industrial water treatment. And let's start with general characteristics of raw materials. The chemical industry is one of the largest manufacturing industries in all developed and emerging countries. While many of the products from the industry, such as detergents, soaps, and perfumes, are purchased directly by the consumer, others are used as intermediates to make other products. The industry uses a wide range of raw materials, from air and minerals to oil. Raw material or feedstock is the basic material from which a good product is manufactured or made. The most basic raw materials are those that are pumped from the ground or mined. Brine and oil are two large initial sources. It's amazing how many chemicals are derived just from these two sources. Other sources of chemicals come from plants, animals, and the ocean. Most chemicals in the market are intermediates. Some things are found in nature, but they have to be extracted, separated, purified, and filtered. The whole field of chemical engineering deals with how to efficiently take either a single raw material and make multiple products out of it, or combine chemicals together to make a variety of products. Chemical processing is part of a larger group called process industry. The common characteristics is that a few raw materials can be used to make many different products. Every element on the periodic table is fair game to be used as a raw material in some finished product. The question is, what is the best source to start with to make the desired product? Chemical manufacturing turns raw materials into useful products for applications in materials, agriculture, health, and other applications. Chemical manufacturing is a subject of chemical industry involved in the conversion of raw materials into value-added products. These products may be more advanced materials or very simple materials that cannot be obtained from natural sources. The raw starting materials are commonly from petrochemical sources. Fractional distillation of crude oil produces a wide variety of valuable materials for the chemical industry. Although the raw starting materials can be extracted from nature, the majority of the raw materials for polymers come from petrochemical sources or crude oil fractionation. Raw materials for chemical industry are classified by different qualities. By origination, raw materials are divided into mineral, vegetative, and animal. In its turn, mineral raw materials are divided into ore or metal, non-ore, and combustible or organic ones. Ore ones include iron, copper, chromium, and other ores that consist of metal oxides and sulfides. Ores containing various metal compounds are called as polymetallic ores. Non-ore raw materials are table salt, phosphorides, gypsum, limestone, sulfur, sand, clay, etc. Combustible fossil minerals are peat, coal and brown coal, natural gas, and shale. They consist of organic compounds and are used as raw materials and energy resources. Vegetative raw materials are, for example, sunflower, potato, wood, sugar beet, cotton, flax. Animal raw materials are wool, fur, leather, butter, milk, etc. Vegetative and animal raw materials are processed into food items and technical products of household and industrial using. By raw material stock, raw materials are divided into non-renewable, extracted from the earth's bosom, minerals, ores, combustible fossil resources, and renewable, such as water, air, vegetative, and animal raw materials. By chemical composition, raw materials are divided into inorganic and organic. The example of inorganic raw materials are ores and minerals, and examples of organic feedstocks are oil, coal, natural gas. By aggregative condition, they are divided into solid, such as ores, minerals, coal, shale, liquid, such as water, brine, oil, and gaseous, for example, air, natural gas, and other examples. By the degree of using raw materials can be divided into primary, such as natural raw materials of different origination, and secondary, industrial and household waste, for example, encompassing gas, side products of primary raw material processing, production waste. Secondary material resources are essential sources of chemical raw materials. They include production waste, consumption waste, and side products. Production waste is raw materials and semi-product leftovers that are formed in the production process and that have partially or totally lost their qualities and don't comply with the standard or technical conditions. Consumption waste are different used products, restoration of which is economically inexpedient, for example, completely broken machinery, glass, rubber, and plastic products, exploited reagents, catalysts, etc. Industrial consumption waste or unusable household and personal use products. Side products are formed in the raw material processing along with basic manufactured products, but do not represent the purpose of the industrial process. However, side products, as a rule, can be used as final products. There is a rich raw material base in Kazakhstan that provides national industrial productions with raw materials. Kazakhstan takes the second place in the world after Russia in explored reserves of phosphate raw materials. The largest basin of phosphorites is Karatau Basin with more than 40 deposits, and the second one is Shilisai deposit in Akhtubek Basin. The largest deposits are Zhanatas, Koksu, Aksai, and Chulaktau. They are characterized by low content of phosphorus oxide and some admixtures content. Phosphorite ores are divided into high-grade ones containing more than 27% of phosphorus oxide, run-of-the-mine ores containing 23 to 27% of phosphorus oxide, and low-grade ores with less than 23% of phosphorus oxide. Phosphorites are used in production of yellow phosphorus, phosphoric acids, salts, and fertilizers. There are large deposits of oil and natural gas in West Kazakhstan in the Caspian Sea area. Kazakhstan is one of the largest centers of Commonwealth of Independent States by coking and energetic coal reserves. The biggest coal deposits are located in Karaganda, Ekibastuz, and Maykubensky basins. There are also several deposits of brown coal. Kazakhstan takes the leading place among CIS by explored reserves of iron, copper, lead, zinc, silver, manganese, aluminum, chromium, and uranium ores. Basic reserves of iron ores are located in Kostanay region in Sokolovskaya and Sarbayskaya deposits. Their reserves not only cover needs of domestic metallurgical companies, but can be exported as well. Non-ferrous metal ores are concentrated in Zhezkazgan and Balkhash area. Aluminum ores are mainly presented with bauxite ores. Largest bauxite deposits taking the second place among CIS are characterized with high quality. Such ores don't require their enrichment. They are mainly located in Kostanay and Akmola region and provide completely the largest Pavlodar alumina plant with the raw materials. Other kinds of aluminum ores are alunite, nepheline, kaolin, etc. They are deposited in central, east, and north Kazakhstan. There is the biggest chromium ore deposit in Aktobe area, Donskoye deposit. By their reserves and quality, Kazakhstan takes the first place in the world. These ores are produced at Aktobe plant of chromium compounds. There are also pyrite and boron ores, barite, vanadium, titanium, and nickel ores around various regions. Magnesium-containing salts, table and potassium salts, sodium sulfate, and are widespread in Atyrau, Aktobe, Pavlodar, and Mangistau regions, and at Aral Sea area. Production and construction materials is totally provided by domestic raw materials: clay, sand, gypsum, and limestone. Uranium ores are mostly concentrated in Suzak area of South Kazakhstan region. Raw materials enrichment is a combination of physical and physical-chemical methods of mineral raw material treatment in order to remove the gangue and increase the content of basic component in the concentrate. In case when there are several useful components in raw materials, it is divided into constituent parts, fractions, enriched with this or that component. These fractions are raw materials for different productions. For raw materials enrichment, different methods are used. If raw materials are solids, the following methods are used: gravitational, electromagnetic, electrostatic, flotation, chemical method. Gravitational method is a separation of natural raw materials based on different velocity of fallout of parts with different density and size. It takes place in fluid or gas flow or under centrifugal force action. An air separator, a cyclone, and a hydrocyclone are used for gravitational separation. This method is widely used for the enrichment of raw materials in production of silicate materials, mineral salts, and in metallurgy. Electromagnetic method is a separation of natural raw materials by different magnetic permeability of components. For example, separation of magnetite, chromic iron ore, rutile, and other magnetic susceptible raw materials from gangue is conducted by this method. Or non-ore solid raw materials, limestone, lime, phosphorite, are subjected to enrichment to remove metallic impurities from the basic rock. An electromagnetic separation is used for this enrichment. Electrostatic method is a separation of natural raw materials by different electric conductivity. Separation of conductive ores from the electric rock, for example gypsum, limestone, silicates, is conducted by means of wire or passage through an electric field. Flotation is the separation of relatively small particles weighted in liquid from each other by their different wettability, by the ability of hydrophobic particles to stick to gas bubbles added to suspension with their subsequent surfacing and foam formation. It is one of the most widespread ways of enrichment used in the larger scales. Chemical method is the enrichment of natural raw materials due to different solubility of raw material components in different solvents and ability of components to enter chemical reaction. These methods include roasting of minerals with the purpose of increasing the content of useful component in raw materials for removal of crystallization water, decomposition of carbonates and removal of volatile components, extraction of gold, silver from ores by their interaction with solvents and transition into different chemical compounds. Leaching of one component from raw materials by treatment with water or non-saturated solution. For example, uranium, or underground leaching by sulfuric acid solution, and salt brine underground leaching by water. Water is widely used in chemical industry. It is applied as raw materials and reagent for many chemical reactions. It is often used as an absorbent for purification and washing various gases and solid materials from admixtures. Another direction of water application is enrichment of solid raw materials by means of flotation or hydromechanical method. In addition, water is applied in larger scales as a heat carrier or cooling agent. Since water is used in large scales not only as potable or sanitary water but for production purposes, then there are stringent specific requirements for water quality. Water quality is determined by such characteristics as transparency, color, flavor, total salt content, hardness, oxidation susceptibility, and water acidity. Water composition, possibility of its direct using for various purposes, or necessity of its preparation is determined based on technical analysis result. Total water analysis includes a lot of different determinations and takes long time. The analysis consists in determination of color, flavor, taste, acidity, content of oxygen, hydrogen sulfide, carbon dioxide, nitrates, fluorides, organic substances, hydrocarbonates, etc. However, the total analysis conducting is unwanted in many cases. One may be limited with a part of analysis only, and determination of various types of water hardness, oxidation susceptibility, and acidity has the largest value. Please answer the questions that you can see in front of you on this slide based on the discussed issues. Here is the list of literature you may use to get acquainted with the material more deeply. And that's all for today. Goodbye.